Hi, this is Ambika, Assistant Professor, Department of AIML. Today we are going to discuss about security engineering. In that we are going to discuss about the risk management and secure design principles. Security engineering is nothing but a process of designing, implementing and maintaining the system which can resist the malicious attacks as well as the failures. So it is closely related to the dependability, which includes safety, reliability, availability and security. Security goals. So the three main security goals are confidentiality, integrity and availability. Confidentiality, it is nothing but protecting the information from unauthorized disclosure. Integrity, that is protecting the data against the unauthorized modification or destruction of data. Availability, it ensures the authorized users have the access to the system and also on the data when needed. So apart from this, some additional security goals are authentication, authorization, accountability. Authentication is nothing but verifying the user identity. Authorization, so it refers for controlling the access rights. Accountability, it is nothing but tracing the actions of the users. Next is risk management in security engineering. Risk management is nothing but a process of identifying, analyzing and mitigating the security risk. A risk is nothing but the probability that a threat will exploit a vulnerability and also causes the harm to the asset. Risk management process. It includes risk identification, risk analysis, risk evaluation, risk mitigation and risk monitoring. Risk identification. It is nothing but we are going to identify the risk. Here the assets, it may be the data, software, hardware or some services. So mainly the threats will be like attackers, malware, insider threats as well as the natural disasters. If you consider an example like student database, your threat will be like unauthorized access to the student database and due to the weak password, it leads to the vulnerability. Risk analysis and assessment. So to evaluate the risk, it is mainly based on the likelihood and also the impact. Likelihood is nothing but the probability of occurrence of the risk. Impact is nothing but it leads to the severity of the damage. So here the two techniques are followed. Qualitative analysis, which is nothing but low, medium or high, and also the quantitative analysis is based on the cost. Next is risk matrix. So the risk matrix is here it is referred as likelihood, impact and risk level. So if the risk is likelihood of the risk is high means then the impact will be high as well as the risk level will be critical. If you consider the likelihood it is medium means then both the impact and the risk level will be high. If the likelihood is low means both the impact and the risk level will be low. Risk mitigation strategies. So it includes risk avoidance, risk reduction, risk transfer, and risk acceptance. Risk avoidance. It is nothing but eliminating the risk by removing the asset or functionality. Next is risk reduction. Here we are going to reduce the risk by applying some security controls. Next is risk transfer. Here the risk will be shifted based on the impact to the third party like purchasing insurance or outsourcing a specific function. Next is accepting the minor risk. It leads to the risk acceptance. Security engineering's requirements. If you consider the security requirements, it defines how the system should protect itself. So there are some types of security requirements: physical, technical, functional, non-functional as well as organizational. Physical, it is nothing but it protects the physical infrastructure of the data. Next one is technical. It refers to the digital data like firewalls, antivirus software like that. Next one is functional. So it mainly leads to the authentication and also the access control of the data. Next is non-functional. So it refers to the performance under the attack and also the availability of the system. Next is organizational. It leads to the policies, standards as well as the legal constraints. Secure design principles. Some secure design principles they are developed from the beginning. It includes like least privilege. So least privilege means users and processors should have only the minimum privileges needed. So in this case, it will reduce the damage from the attacks. Next is defense in depth. It leads to the multiple layers of security controls will be applied. For example, firewalls, encryption and authentication. Next is fail-safe defaults. Here the default access will be denied and even if the system fails, it should fail securely. Secure design principles, it also has some of the principles like separation of concerns, economy of mechanism, secure by design and secure by default as well as zero trust. Separation of concerns. Here the system will be divided into the independent modules so that there will be limited spread of the attacks. Next is economy of mechanism. Here we have to keep the security mechanisms very simple so that the simpler systems they may have the fewer vulnerabilities. Secure by design and secure by default. Security will be considered during the design phase, and also default configuration should also be secure. Next is zero trust. Here this is a modern principle of the secure design. Here the principle is that never trust, always verify. Common secure design technique includes authentication mechanism, access control models, encryption, input validation, and audit logging. Authentication mechanisms like passwords, biometrics, and also multi-factor authentication. Access control models includes role-based access control. Encryption will be based on data address, that is the data stored in the databases, and also data in transit. Next is input validation. It is used for preventing the injection attacks. So audit logging will be done by monitoring and also due to the accountability. Threat modeling. So the threat modeling here, it identifies the potential attacks during the design phase itself. So it identifies the threats using the STRIDE model, STRIDE. So S stands for spoofing, nothing but cheating. Then tampering, like altering the data. Next is repudiation, like rejecting the data. Next is information disclosure, denial of service, and also the elevation of privilege. Relationship with a dependable system. So these security failures, it leads to the loss of availability. Some safety hazards should be taken, and also it leads to the legal and financial consequences. So the security, it acts as a core component of the dependable system. So this is a summary of the security engineering. Thank you.